Hi, everyone, and welcome to this session. I'm Kate from Link Digital, and today I'm joined by Steven DaCosta, our Executive Director, and Oleksandr Cherniavskyi, one of the CKAN experts, to walk you through Ask AI, the AI-powered feature built on CKAN. So in this session, we will show you how Ask AI works and what it can do, and why it matters for anyone managing open data. Let's get into it. So Steven, the virtual mic is yours.
Thanks, Kate. Yeah, so this is a follow-on from a session last week and work that's been ongoing for a while. We just thought from the position that we're up to, we've had a chat with a number of clients about how to integrate AI with something like a CKAN portal and how to support search with natural language processing, chatbot style. But there's a lot more to unpack with regard to the whole pipeline of using AI in something like an open data portal. And we think the way that we've approached it has created the right space to address all of the types of issues that our customers might have, and CKAN implementers and platform managers as well. And so Oleksandr is able to provide a demo and sort of just walk through where we're at today. We have more work to do and we have more refinements like anything, but it's less about that. I think it's more about the environment of AI being used with data and being used in the context of a data portal. So after we get into it, I think there's a little bit of a chat to be had to try and just raise the profile of some of those opportunities, challenges, and ways of moving forward. So Oleksandr, I understand you've got something like a demo we can just walk through and just sort of show folks to start with how Ask AI works.
Really a simple presentation that I have created using the markdown file because I'm not a designer of some kind, etc. But it should show the ideas that we have. So usually we should start from the problem. And I've been talking about the problem that we have in CKAN. The main problem is you have hundreds of datasets or thousands of datasets. You can have 100,000 of datasets on a portal, and when user visits your portal, he needs to find some data. Usually, it's a few datasets from the whole bunch of datasets that you have, and it's called the discoverability. And we've been trying to solve this issue for quite a while in CKAN with different things. Mainly, we have this search that is powered with Solr. Some portals, some data portals use ElasticSearch. Basically, it's the same thing. This is a search engine that allows you to find something with a query, but the way that it works, it's usually just compares the tokens inside your query, like it splits it by the words, removes the endings, and then it's just trying to find something that is close to your search query inside the metadata of the dataset. In CKAN, we usually use the notes or the description field and the title of the dataset. This might be not enough because on different portals, we have quite a while of custom metadata fields, for example, like temporal resolution, some kind of new fields related to authorship, a lot of some spatial fields. I mean, there are dozens and thousands of fields that are something that doesn't exist in CKAN from out of the box, but different portals would like to add them. And when you search within a Solr, obviously you're still using the title and the description fields. It might be not enough. So we want to help you to find the right dataset faster and make it a bit more smoother experience than it is right now. Then we have decided to create the knowledge assistant. Basically, everything is about AI nowadays, and we might be happy about it, we might be not happy, but it is what it is. And we had to do something related to AI, and we started from the knowledge assistant. Basically, the first thing that we wanted to do wasn't actually the semantic search. We were aiming to create an AI agent that can help you to navigate the data portal. It doesn't mean that it has to be search, because there are quite a few different things that might be interesting on data portal. For example, some data portals introduce new features, like a card to add datasets, a data request feature, a data quality and assessment tools, etc., etc. And this is something that doesn't exist in CKAN out of the box, and it was built on top of the CKAN. So when client visits a portal, it's something completely new, even if they have seen different data portals before, it might be something unique, and someone should explain them how to use this feature. And we thought that maybe if a knowledge assistant can have a knowledge about this feature, and it can explain it inside the chat, like with a human language, that is most important right now. And we started to move in this direction. And then we thought maybe it can explain something about the data. Like we have a lot of tabular data. We have a lot of different data. It might be geo data, it might be some PDF, a lot of tabular data, CSV, TSV, Parquet, Org, Feather, etc., and all of them. And we started to move in this direction. And why the semantic search was the first thing? Because when we gathered all the data that we have, not all of them, but all of the data, but some formats, because we obviously we can't work with any format, because every format requires an additional step to write some kind of adapter that takes the data and transform it into a different format that will be understandable by the large language model. But we started to with the CSV, for example, we are taking the CSV and using the embedding model, we are transforming the text data. The CSV is a plain text. We are transforming it into some kind of some things that's called embeddings. It's basically, it is a multidimensional vector that is stored in the Postgres, because Postgres has a vector extension and allows you to store those vectors into column. And it stores like a bunch of let's say float numbers that somehow represents something that doesn't matter for this code. And when a user, for example, writes something in the search, like a police reports or ocean pollution, imagine that we don't have a data set that represents this specific keywords, like ocean pollution doesn't exist in a portal, but we have something like marine ecosystems or environmental hazards, and it might be somehow closed like in terms, because if I'm looking for ocean pollution, I might be interested in something else, or I might be typing something wrong, or I might be looking for a wrong term because I don't actually know what I need, because sometimes it is the case. And we had those embeddings created from the CSV file, for example. And the like how to say, the side effect of the ideas we were creating, the AI agents that can operate with the data, was the semantic search, because semantic search requires you basically embeddings, and if you have those, you can transform the user search query into embedding as well, and just let's say compare them. And it's a very quick way to implement a semantic search. You see this GIF is actually from the UI, and it's not sped up. It's actually work quite fast. So there is no extra toll like we have when we use the language model and like query it with some questions. When we use a semantic search, we use just the database and the embeddings that we have created before. It's quite fascinating.
Just a second. So just sort of like for folks sort of listening along, things like semantic might skip over people's way of understanding the world. It's like a meaningful, meaningful bag. You put all your
or similarity search. I might call it like that.
So in terms of accessibility, it's like a user comes to a data portal. They have a goal. Their goal is meaningful to them. That's like a semantic identity to their search or their action. at a data pool. They might use any number of words to try and like articulate or spell out their goal. They might use ocean population, for example. The idea is that when we've got embeddings and when we've got an AI model, it's already got that goal orientation. It understands the semantic alignment, the kind of meaningful alignment of someone who might have a goal, and they might use language to express that goal. So really the semantic search is about bringing those two together, irrespective of what the word is or what the language is, what the way a person expresses their goal. It's about understanding that goal alignment and then bringing the data in front of them. So like that's the way I would sort of kind of understand it and sort of think about it in the way that we're updating that data access layer, let's say. Would you agree with that?
Yeah, and also it can be called similarity search because you see there is a blue label at the title of each dataset that was fetched from the let's say vector storage, not from the Solr. So the bottom one here was actually what Solr would like to show you, and the labeled ones are from the vector storage. And you see there is a percentage that we might think that it might be relevant. It's so-called similarity search. It's like a number from 0 to 1 that can be easily represented with percentages. So we might think that 51% that it's something related to your search.
Yeah, cool. Sorry for the interruption. Yeah, keep going.
No worries. It's very helpful when you talk, and I don't have to talk a lot. There is also another picture of the semantic search. Previous was like this one word, and actually you can ask a few words. Here I ask crime statistic in Canberra. I don't know if this data exists somewhere, but what I have found in my test data is very nice because it's you see domestic violence somehow related to crimes, and educational participation in Australia doesn't relate to crime, but it's related to Canberra, and somehow know that Canberra is related to Australia, even if those are just vectors and numbers in the database.
Yeah, so that would be an example of a thinly traded market when it comes to semantic kind of covalence, or the way in which two different words should have an overlap. If there isn't a strong correlation or a strong kind of weighting between the two, then you can get those siloed responses. One weights Canberra, one weights crime, but there's not enough like trade in the embeddings to understand whether or not Canberra crime data is going to be more relevant. That's cool.
Okay, so what we did also is obviously an AI agent, and semantic search is just a part and the side effect of the things that we've been doing. And we thought that this might be a good idea to place the semantic search inside the same extension, but mostly the knowledge assistant is what you see right now. On every page, you will have a button that will open up the conversation model, where you can chat. Obviously, you are familiar with this concept. It is everywhere. Even before the era of AI, we had those models, but you've been chatting with people. Right now, you are chatting with the language model, and you can ask something about the data set that you have in the portal. And it is a context aware. It means if you are opening it from the search page, you see there is a label searching all datasets. If you will open it from the datasets page, it will pass the dataset ID. If you open it from the resource page, it will pass dataset ID and the resource ID. It's done to fetch the right data when user needs it, because there might be a lot of data on the portal, and we just should have somehow narrow what are we looking for. And here I'm asking for some kind of data set related to fund distribution. It gives me a link and it says, yes, we have it. And it's very nice. as I said, this is context aware. So here we are in a dataset mode, and what you would like to ask about the dataset, something related to authorship, to license, to other metadata fields, and etc. etc. In this case, it knows the metadata of the dataset, or this dataset, for example, doesn't have any resources. It knows when it was updated last time. Maybe I'm not very creative in asking questions, and I mean, users probably knows better when they need them. As a developer, I don't have any question about the dataset. I have answered it to myself a very long time ago. We have an integration with DataStore, and it's a very tricky part. DataStore API has an API action to query the data store using the SQL. And we are utilizing this API action. We have a model that is generating an SQL query based on the user query, based on the human language. We are transforming it into an SQL query. And then we are using this API. It's not a security concern because you can just use any arbitrary SQL here, because we are guarded by the rails of the data store API action. And we have an idea how to improve this, because currently all that we are showing you right now is working within the local models. We are not using OpenAI, Claude, etc. Everything is running, in this case, on my laptop, on my MacBook M1 Pro. And it might be improved in different ways. For example, you can use an external model, the cloud one, and it's obviously an improvement in terms of speed and accuracy, but it also might be a security concern for you, because if you are working with some kind of, if you are a government organization, you are working with private information of your citizens, or maybe you are a medical school, or I don't know, you have a lot of private data. You don't want to pass this data to other people. In this case, your probably only way is to use a local model. Local model can be very powerful, obviously. This is a slide about security. Part of this is...
Before you move on, like there's kind of an example about local models, and we might as well use Canberra, right? So Canberra and crime. Let's use that as an example. So if I'm going to go out and into the city in Canberra, and if I want to get some directions, and I ask someone I come across, where's the taxi rank? Now I could ask everyone in the city, and then I would have an aggregated weighting of where the taxi rank is, because the model was generated. My model of understanding was generated by a statistical survey of everyone that's in the area. And I think that's kind of like really important. So it's not just that a model has a way to have language and can respond to the kind of language that you're using to tell it your goals. It actually has to have an orientation that is localized to how it understands what goals are. So it's like a geographic or a relational understanding. So there's kind of two gotchas with using any AI model. One is it might have a very biased understanding of what's important. You might ask, where's the taxi rank? And if the model was developed from a space that had taxis and dirigibles, like airships and buses and trains and subways and all this kind of stuff, it might say, well, the taxi rank is over here, but you've got this other option as well. And that kind of bifurcation, that kind of additional knowledge is not helpful to the context of the person asking the question. It needs to be very localized. So local AI that's really trained for two reasons. One, to be consistent, like you consistently know how it's going to perform under situations. So then you can train or align the way in which it answers questions to be safe or to be appropriate. Or it's one that's trained on particular kinds of knowledge. So that's additional kind of work that we're getting ready for, because you and I, Alexander, have spoken about this. We know that it's not about external AI, it's about internal AI, not just for governance, not just for control, but because there's no engineering unless you've got like an internalized view of how you control what gets created, what gets the input and output. So I think the way I look at it, and I know the way we've kind of discussed in the past, is that working with AI with data, working with AI in any context is about knowledge engineering. It's about knowledge operations. And you really have to understand what the inbound knowledge is that created something like a knowledge engine, a model. You need to know the inbound knowledge of, say, users and their context. And you need to know that there's enough of a gap or not enough of a gap to understand when the wrong questions are being asked for the model that you've got. And so basically, you know, if in Canberra, I have a model that knows everything about transport, and I ask it where I can get a ride to Mars, we have no space station. We have no, you know, it might hallucinate an answer because it has enough an understanding about transit and places to get on and off and public transport, but it doesn't have enough information to know where the space station is, let's say, or the whatever it might be. That's it's a bit of a surrealist example, but that kind of software engineering is really important when it comes to data portal. And if you're using AI correctly, as in you use the real power of AI, I think that's the kind of engineering that's really important for something like a CKAN integration. Because like you say, a lot of our customers are government. They really care about their data. Data's that's the reason why the portal exists. So they want to be able to understand the context of questions and deliver the right context around the data, but not get caught in hallucinations and not get caught in ungrounded assumptions to supply things that shouldn't be supplied. Anyway, I interrupted again, but I kind of wanted to say that.
Okay, thanks, Steven. Let's get back to the slide, and this slide is about the security. Security is obviously our main concern when we were developing this extension. There are few, if not few, two main things related to security. First of all, we are utilizing the CKAN permissions. We have so-called permission labels in CKAN, and each user have an array of permission labels, like a list of permission labels that you have. Like, for example, if you are an administrator of an organization, you have these permission labels that says org admin -ID of this organization. If you are just a regular user, you have this label called public, and all the datasets and therefore resources on the portal have permission labels that are calculated every time we are updating it. For example, if you switch the dataset to private, the permission label public will be removed from the dataset. And when we show the dataset to the user from the Solr, we are like comparing the permission labels of the user on the dataset and excluding or including them based on those permission labels. Basically, we are using the same thing here. Below you have two screenshots. On the left, you can see the private dataset, and AI suggested you the emergency housing and shelter usage. On the right, you are an anonymous user. You don't have this dataset because it was excluded, and not by Solr, but by us, because we are using the same idea as CKAN. And the second part is that all you are doing is staying inside your infrastructure. You are going to host the Ollama model. There are a lot of different models inside there. We are suggesting you to use a few exact ones, but you can choose any that supports a few concepts that needs to be supported. I'm not going to talk about it. And you can use obviously some kind of closed solutions. But if you want to your data to stay inside your infrastructure, you're going to host it. I probably don't have a slide related to costs and the hosting of those models. I have to say that might be a bit expensive, but probably using the cloud solution is also not free, and it costs you some money. It's based on how many tokens you are using, basically how much things the model generating to your user, how often they are querying it, and it's not going to be cheap as well. The cloud solution have its advantages and disadvantages as the local one. You don't have a magic, I don't know how to say it, magic bullet or something that can solve both things without having any disadvantages.
There is a sort of simple way to think about it though. So all computer infrastructure is one of three things. It's either network costs, it's storage costs, or it's computational costs. And even though an AI model is it's like a solid state knowledge type thing, you still have to run it to get an answer. So the question is, how will the component of that being sort of storage change when we have different network dynamics, so multiple concurrent users? So if we're not going to do things like cached answers or like a second stage statistical delivery of the types of questions that people ask and match those to the previously AI rendered answers to those types of things, if you're not doing those sorts of optimizations, you're going to end up having high CPU costs. And you won't necessarily need those high CPU costs because the architecture itself, you would want to optimize to do these sorts of like knowledge caching models. So the pipeline, as I see it, is still around software engineering or infrastructure engineering to understand what are the dynamics of the user and the diversity of the types of questions they're asking. Does that diversity and their goal orientation, what they're looking for, match with the diversity of the type of data that you have? Because AI just might not be valuable if you've only got 48 data sets. If there's a lot of natural segmentation around your data sets, such that people can like browse through faceted searching, like go through this is our environment data, infrastructure data, and they can more quickly find very different selective method, then again, the conversational method may not be the one to use. You don't want to over-engineer something that's going to be computationally heavy when you can put the load of that on the user to have them select by a facet. So all of these things are actually why I see this as software engineering. It's user experience engineering. It's the business model of the data portal holder and how they generate value, whether they want to invest in a highly diverse, structured sort of response from an AI model. And also, the local model in terms of the embedding and how often that's updated will be a characteristic of what people want to do, because any model itself is a time capsule. It's an internal geometry or a representation of an external understanding of things like language, and language is very fluid and it's very context specific and it's very brittle to current events. It's time, it depreciates. So how often people want to change their language, or how generic they want the language model to work, or how rational it might be in terms of chain of thought reasoning. These are all considerations. So I like that the way we've approached it so far, Oleksandr, is it's software. I've a lot of focus on configuration, the inbound configuration of what data sets are securely embedded or not in terms of the governance, but also the outbound in terms of when a result is shown, is it from Solr? Is it effectively from the indexed Solr, or is it from the AI suggestion? And that gives us a lot of ways to change that over time. And it can even be filtered based on CPU usage. So you think about a time when you've got a lot of activity on your site, but the activity is coming because there's a particular thing going on. You've released a particular report. Most of the planet is looking for that particular report. When you have that localized contextual, it's like so in MCP, model context protocols, like a server-side context to how you deliver information. When the outside world has a context that they're kind of converging on, they all want the same report, you don't need to supply highly contextual search. You can pretty much assume that they're all looking for the same report. So that kind of dynamic flow of search approach and response approach, I think is going to be the way we understand how infrastructure gets used in knowledge operations. Because the other thing is, AI models are like grossly inefficient compared to database queries. If you're looking for something like super specific, at kind of like that record level into a database. So the kind of search that can be algorithmically done into a known data structure is not the kind of same search as is done into a model. So, it's going to be horses for courses, and lots of testing, I think, to understand how much it's going to cost and what people want to invest in over time. How's that, Oleksandr? Same answer as you, but with more detail.
I guess I lost the plot at some point. Before going to the next slide, I wanted to say about the costs, and we actually hosted the 9 billion parameters model at AWS, and as I said, Joel said me that it will cost us $383 a month, and it can be reduced to $225 if you reserve it. But the highest spec version of the T4 GPU instances is a bit more than $3,000 per month. So it can be very different from $400 to $3,000 per month. It depends on you and your needs, because I will talk about the model sizes later. The ones we are using for this demo is 9 billion parameters. It is a small model, not even an average size. And when you are talking to, for example, ChatGPT or Claude, for example, the 5.1 or 5.2 from ChatGPT, they do not expose the information about the sizes of those models, because it might be some private information and you don't want your other rivals to know about it. But there are assessments that it might be from 3 to 400 billion parameters to even 1 trillion. And it's not like a big model. It's something that you won't be able to host probably on your machine. Let's go to the next slide.
I'll say one more thing as well. In terms of the business value and the timeliness. So there would be models or approaches by which people follow particular data sets, or they have a stored query or a stored interest. So they have a profile of things they're interested in. Just how at the moment we can allow people on CKAN to follow an organization, or to follow a group, for example, or to follow a data set for updates. That kind of model of active delivery against the profile of a user can also be supported by this embedded search model. And that's also a way to think of, like, once per month, you're running the engine to support your users, your subscribed users, your registered users, your profiled users, to give them the kind of updates. And that's another way of thinking about it. It doesn't have to be, like, the goal of a user doesn't have to be at the search bar with the words and the terms at the moment when they're currently looking for a data set. It can be preset, and then the delivery of that with the AI augmented responses can be managed in that way as well. Maybe not right now, Oleksandr. I'm not saying it works. I'm just saying that's the kind of engineering we're thinking about, right?
Yeah, but I think that $400 or even $1,000, it's not the big cost if you have like thousands of users and hundreds of thousands of data sets. It's just a cost that you probably willing to pay if you want to use these new technologies. Let's talk about the supported file types. At the beginning, I said already that we aim to a few popular resources types that we have on different portals. Obviously, the most popular are tabular data, and we have we implemented so-called readers. Each reader works with a specific file type. For example, CSV reader, SSX reader, and it obviously allows you to create more readers if you need them. For example, if you have different other formats like Parquet or Org has also tabular column, tabular data, and you want to introduce them, we can add the support of them, but currently we don't have it. All that readers are doing, they read the data from the resource and somehow helps it to convert it into the embeddings, and not much to say about it. We have also a flexible AI backend. This is, I've been talking about this as well. We have an Ollama by default, this local model. It's the best for if you have a security concerns, you want to be privacy first. And the OpenAI is for more high quality responses. It's cloud-based, and we can add more adapters for different providers. For example, we are planning to add an adapter for Anthropic, I guess, is the cloud model, and we can add more. It's not a problem right now. It's just not our goal, because we don't know what the client wants at this point. If they will want to work with the Anthropic, we will do it. It's fairly easy to implement, and you also can configure it from the CKAN config file, and I will talk about the configuration right now. There are a lot of things that can be configured when you're working with language models. Mostly it's narrowed down to the temperature. Temperature is like a number from 0 to 1 that represents the creativity or determinism of the specific model. For example, if you go high temperature, it will be more creative, and then it will accept the same context. It can produce different outcomes, different responses. It's better to use not when you want to get some specific response, as it should be accurate. In this case, you would like to use it when you, I don't know, using the AI agent to help you navigate the portal, explain some concepts, and it should be more creative. When you want a more deterministic approach, is when you are generating an SQL, for example, or working with tabular data. We can configure like a number of documents we are retrieving from the vector storage. We can enable, disable semantic search and control a few different things about it. There is a thing called query expansion that I didn't talk about it. It's also related to semantic search. And it is like, for example, when you have a query, we can expand it and like suggest to a different other things that might be relevant to your search, to the like to compare it to the vector storage to enrich the results you are getting. We also can configure data store result limit. Context window for Ollama is like a size of information that it can take at once and without forgetting the previous things that you've been talking to it. And thinking mode is like a think inside model that allows them to contemplate about things like a real human beings. It might improve the results, but it's also makes it thinker much longer and taking more resources from your tech. And there is a GIF that shows that we have a lot of things that can be configured from the UI. It means that it can be configured on the fly, and there are a few things that cannot be changed when you have started the CKAN portal. Mostly it is something related to creating embeddings and your main model. If you want to change from Ollama to OpenAI, you cannot do it on the fly because you will have to probably change the embedding, re-index the data because embeddings might be different dimension, etc. So there is a summary. What we have a similarity search or semantic search. We have an ask question feature to talk to your agent, and you don't need an SQL skills because the LLM will identify when you need to actually query the tabular data from the data store and try to generate the SQL for you to give you required response. And that's it.
Questions? So I've seen this before. I obviously know a lot about it, and I would just have to reiterate the reason why we've got a lot of those configurations directly available is that's the way in which an organization will have some control in the profile of their AI use case. And the profile for one AI use case will relate to that matching between organizational requirements and user requirements around the data itself. And use cases themselves will be different for different kinds of stakeholders. It might be like a data domain stakeholder. So infrastructure versus climate might have different tolerances for creativity, for example. The ability to find things that are relatable, or that kind of zooming in and finding additional types of questions to ask, that semantic expansion, might be appropriate for a person who doesn't know what they're looking for in, say, a business context. What are the options for grants across the country? I think there's something called this. Would you like to look at these other things as well? Not just grants, but innovator programs, incubator programs, things like this. So the context of the business requirement, context of the user requirement, and the way a business tries to match those will be very relevant to the way that the configuration of this kind of access model is used. So I think our starting point is to expose as much as possible, look for the governance methods to align this to the data and the custodians, and go from there. But it's lots of fun at the moment. The data itself, I think, is, people talk about way back in the day data being the new oil. I wouldn't say that data is that fluidic. It's much more static, but the way we use data is fluidic. So we need to have the way in which we configure our view of what data is. And that's very much related to our own perspective, whether it's as an organization, a user, or as a custodian. And the way you get that perspective change is through configuration, engineering the data pipeline, engineering the embeddings model and approach, and allowing for all the configurations. So I don't have any questions, Oleksandr, but it's cool work and it's fun.
Yeah, we wanted to make it flexible to allow tweaking it here and there, because there are a lot of things that can be changed about the behavior of those models. We're also using different models for embeddings, different, we have at least 2 models that do different things, and we might introduce more, because it seems that this approach in tech, when you are using different model for one narrow specific use case, for example, we might introduce a new model that works only with SQL. If you will find a model that perform better than generating SQL than our main model that we are using, we might introduce a third model. It's necessary to say that we have a few dozens of options, config options, but all of them have default values. You don't have to change anything, basically. You have only configure the Ollama model the same way that it is configured by default, and it should be exposed by some URL in your local, in your net and your network, and it will work. If you want to change something, you have this possibility, and we think that this is a professional approach when you go deeper and try to understand how things work, to understand why we need those config options. And you might not know it, but if you have someone that understands why you need to change the temperature or use a different model with different dimensions, you might want to change it, and we're giving you this possibility.
Yeah, absolutely. But also, imagine one of the first applications of machine learning to test the limits of sort of computational prediction and, I guess, system knowledge or game dynamics would be chess. And right now we have that kind of opportunity as well, between a organization that has a whole collection of data and then a user or an end user that wants to have a relationship with that data. It can be like a chess game. Someone is requesting something, the context of that can end up becoming a state that can be stored as a state for a secondary response, like over time, this kind of state management is more like a chess game. It's no longer just a search query and finding the most, probabilistic response to a particular query. It's a chain of experiences or chain of query and response that helps play this game and finds the best solution between the two parties, the data supplier and the one who needs the data. And that kind of state management, I think, is where folks are looking to move eventually, not just transactional language query, but really delivering long-term sustained value over state management and this kind of augmented AI knowledge experience. But thanks. Awesome. We'll probably wrap it up for there, and we've got lots of iterations, so I guess we'll just keep building this thing, right?
Yeah.
So thank you, Stephen and Oleksandr, for working us through Ask AI and what it means for organizations managing their data. So if you'd like to learn more or see Ask AI in action on your own CKAN portal, reach out to us at Link Digital. Thanks for watching.